we can start. So we'll be solving questions from tutorial sheet 4, 10, 15 and 10, 10. So this one is from 10, 10. The question reads, it's saying a pump is needed to lift water from a well. Was that supposed to be through a height of 3 meters at a rate of 0.6 kg per minute? What must be the minimum power of the pump in watts and in horsepower? Okay, so it will be more like a group discussion. If you know what we're supposed to do, then you can contribute. Yeah, then I'll be able to explain as well. So what are we supposed to do here? Let's do first.
We can bring up the formula for power.
Okay, but first let's come up with data before we do everything.
Okay, data.
Yes.
You have the height.
We have the height,
That's
3 meters. What else do we have?
you have the kg per minute.
We have the kg per minute, which is we can consider that one as what?
We can do that as that. Okay. For me, I can just plug in the formula.
Okay, so okay, 0.6 kgs per minute. Okay, then what else? Okay, so now from here, after coming up with the data, the question is asking us to calculate the minimum power, the power in watts and in horsepower. So the first thing is, if you write your formula to say power is given by the work done divided by what? Time, right? Does it make sense?
Yes, yes.
Then what's next now?
We can split the weight.
Yeah, we can split the work, and we can say work is going to be given by force times what? The displacement, right? Displacement over t. Again, we can also do what? We can split the force, and we can say mass times g, right? Times d. Isn't it g?
Yes, G.
Times d over t. So now, after writing this formula, you see that this formula, you have got if you can check there, our formula, we have got mass, and we do have mass there, and we also have the time we also have, although it's in minute. Then we also do have the distance. At the same time, we have the g, which is 9.8, meaning there's nothing difficult there, guys. So if we can check there and say power is going to be given, the mass, we know it already, it's 0. What? This, maybe you are confused, this kg per minute is the same as if we can do this. If we can say power is going to be given by mass over time, then times gd. So this mass is in kgs. You know that it's going to be in kg. Then time is in minute. But we are going to convert that one into what? Seconds. So now let's convert that one into seconds. What are we going to have? So we are converting 0.6. We have got kgs. Now we want to convert it into what? Seconds. So it's going to be minute. So you do this, the dimension analysis. You are going to say, in 1 minute, how many seconds do we have? 60, right? So we're going to have 60 seconds. So now I want to convert that one. Then I'm going to say 0.6 by what? By 60, and I'm getting 0.01 second. Oh, sorry, 0.01 kg per second. We have converted 0.6 kg per minute to 0.2 kg per second, because we want to plug in here where there is kg per what? Per second. Have you seen?
Yeah.
Yes.
Yes.
Therefore, in this formula, we are going just to plug in the whole of this guy is 0.1. So we're going to say P is going to be given by 0.01 times 9.8 times the distance, which is 3. So get your calculator and find the answer. What's the answer? So the answer is 0.294 watts. Do you think there's something difficult there, guys?
No, sir.
Now the question again is saying, what of in horsepower? We talked of horsepower the day before yesterday. We said that if I want to convert 1 horsepower is what? We said that 1 horsepower is 4. 1 horsepower is, yes, 746 watts, right? So now I want to convert that one. If just do dimension analysis, you say 0.294, that is watts. Now you are going to set the units in a such a way that they should cancel each other. So you are going to put horsepower on top there, then down there you put what? The watts. So we are going to say in 1 horsepower, how many watts do we have? We have got 746. Then watts and watts, they are going to cancel out. We are going to remain with horsepower. So you do that answer by 746. You put it in scientific notation. It's going to give us 3.941 times 10 to the power negative 4 horsepower. Any question?
So this dimensional analysis for watts and power in the exam, are they going to give it?
No, you have to know it. They don't give this one. So you have just to know that 1 horsepower is given by 746 watts. They don't give this one. You just need to know. Okay, it's the same as in 1 kilometer there is 1000 meters. They also don't give this one. Okay, is it okay? Is it okay? Okay, so let's go to next question. So the next question is this one. So basically we need just to understand something, guys. When the moment when you read the question, understand what the question wants us to do. So the question is saying a bed of mass 15 grams is riding on a wire. It has a speed of 2.0 meters per second at point A, meaning that is our initial position. At this point we have got initial velocity as what? 2 meters per second. Okay, then they're saying that at its top, as it reaches at the at point what? Point C, the length of the wire, so the length of this wire from A to C is what? 250 centimeters. But we can change this one into meters, and we can say that it's going to be what? 2.5, eh? Is it okay? We can say that it's going to be 2.5. Yes. Then again the question continues to say how large an average friction force opposes the motion of the what? Of the bed. What we need to understand is that this: the total mechanical energy of the initial has to be equal to always what? The final. So now when this guy starts moving from this point going there, we know that at this point we are going to have the total mechanical energy, which is the kinetic plus what? Potential. At initial position, at this point we don't have friction, but the moment when this guy starts now moving, it's going to experience friction, especially at this point, from this point to that point. So that friction Are you here?
Yes, I can get you.
Okay, so now I was saying, at this point, at point A, what's going to happen there is that we are going to have the kinetic energy initial plus the potential energy initial. When we add these guys, we are supposed to get the mechanical energy. But again, this mechanical energy, it is supposed to be equal to the final mechanical energy. But what's going to happen here? The moment when this guy starts traveling until it reaches there, at this point up to that point, it's going to experience friction here. Therefore, this friction, the mechanical energy is going to be reduced. Meaning at this final, if I can add the work done by the friction force, meaning if I add these two, the mechanical final and the work done by the friction force, is going to be equal to what? The initial mechanical energy. That is what we need to understand. So initially, when the object was on top there, it had no friction force. But when it starts now moving, the friction is going to be there at B. So for us to find the friction force, we need to say the initial mechanical energy has to be equal to the final mechanical energy plus the friction force. If I add the friction force, meaning it's more like we are balancing the equation. It's the same as if I say the initial, this equation is the same as this. I say, the final mechanical energy plus the work done by the friction, or I can say mechanical energy, the initial one, if I do minus the work done by the friction, has to be equal to mechanical energy final. Before we continue, please ask. Is okay. It's the same as okay. It's the same as we have this. It's more like we have got point A and point B. Okay, and now they are saying that from point A to B, the work done for it to happen from point A to B is just basically at point A is 250 joules. Have you seen? Now, we are saying that actually we are recording all the classes. Yeah, it's being recorded. Okay. So I'm saying that if we have got at point A, we are saying that the initial mechanical energy, if you can remember what we said, the initial mechanical energy has to be equal to the final mechanical energy. This is the general formula. The mechanical energy initial has to be equal to mechanical energy final. So now, we said that this guy only works when there is what? When there is no what? Can someone remind us? When there is no friction. Yeah. Yes. Conservative. But in this case, it is not conservative because there is what? Friction. So now, if there is friction, let's say that some amount of it, like if the object is moving from point A all the way to point B, there is friction, and let's say the friction, the work done by the friction is 50 joules. What will be the final mechanical energy at this point, at point B? 200. But as we want to balance, we want to say this point A has to be equal to point B. So for me to get the 250, am I not supposed to get the mechanical energy final plus the friction force, which is 50? So 200 plus 50, then I'm getting back to 200. Have you seen? Yes. So now, initially, when we just see the question, just analyze it. At first, we didn't have any kind of friction force, but as it was moving, the friction was there, meaning the initial mechanical energy for us to balance has to be equal to the final mechanical energy plus the work done by the friction. The moment when you write this, then you are home and dry. So the initial there at point A, what do we have there, guys? we have the initial kinetic energy, which is going to be initial kinetic energy plus the initial potential energy, has to be equal to, then at point C, what are we going to have at point C? At point C, we are going to have the final kinetic energy plus again the final potential energy plus again the same guy, the work done by the what? The friction force. Have you seen? Yes. So now from here we start now writing the formulas from the data which we know. If you want, let us write the data here. We have got the H final as the, what is our H final? 50 centimeters. Then we have got H initial, which is 80 centimeters, which this one is the same as 0.5. This one is the same as 0.8 meters. We also do have initial speed, which is what? 2 meters per second. But we don't have initial, this one, the final, when it reaches at C, the final is going to be 0. So now let's now continue this formula. So this formula, we are saying that this one is going to be half mv initial squared plus mg h initial has to be equal to half mv final squared plus mg h final plus the work done by the friction is going to be the Fr times the displacement. You can say change in d or just d. Now someone is going to ask, why is it not negative? Basically, if you can remember yesterday, we shifted this guy. It was we said the general formula was if you can remember very well, we said it was change in PE plus change in KE plus the work done by the friction has to be equal to 0. You remember? Okay, anyway. Okay, so now what's happening here, guys, is this. What's happening here is this. We have got, if we can check from the data which we have, our final friction, our final velocity is 0. What do we expect where there is final velocity, where there is final kinetic energy here? It's going to be 0, right?
Yes.
But we do have the initial, we do have this guy, we also do have that one, we also do have that one. Allow me to go to the next page, or maybe you need okay, is it okay to everyone? We continue. So my goal is to calculate the Fr. What should I do? I'm remaining with half mv initial squared plus mgh initial has to be equal to mgh final plus frd. Let's shift this guy to the other side, and if we do that, and we are going to have half mv squared plus mgh initial minus mgh final, sorry, has to be equal to frd. Let's divide both sides by d. Therefore my Fr is going to be given by half mv initial squared plus mgh initial minus mgh final, everything divided by d. Let's plug in the values. This is the reason why I even told you yesterday, just by writing the formula, everything is going to be there as long as you come up with the data. So now let's see what's going to happen. So we're going to have our Fr. Let's plug in the values. Half the mass. Do you have the mass? So the mass is 15 grams, which is the same as what? 0.015 kgs times 0.015. It's okay, right? then times the velocity, we know it is 2, we square it, we can put them in brackets if we want, times, oh sorry, plus the mass again 0.015 times g 9.8 times h initial is 0.8. This is 0.8. We can also put it in brackets, we do this, and we can get rid of this. Okay, then we say minus the mass again 0.015 times 9.8 times h now is 0.5. We divide everything by the displacement, which is 2.5. Let's find the answer. So what will be our FR? If you do direct, 0. Those who are still struggling on how to use calculators, please let us know. Okay, let's confirm. Anyone having challenges on how to get this answer, like when punching on a calculator? Is it okay? We continue. Is it okay? We continue.
I guess it is okay, sir.
Okay. So that's how we are supposed to answer that question. Then now we also have this one. This one is the one which gave a lot of guys headache. Like the question is saying, is it SK, SK or SK? Okay. That word which is there, traveling at 11.0 meters per second, reaches the foot of the state upward 19 degrees incline, and grid. This grid glides 15 meters up along this slope before coming to rest. What was the average coefficient of friction used? It's possible we can use that method which you are supposed to use, and those guys who are doing 10-15, the question which came in your test, question 30, you can also use that method, but here they have specified to say we should use what? Use conservation of energy method or work energy theorem, the ones which we are doing yesterday. Okay, so first thing, let's come up with a free body diagram. So free body diagram is the one which is going to help us to find everything. Okay, so there, as we can see, was it going up or it was sliding down?
I guess going up.
It was going up.
Incline.
Yes. So now if we let's draw our incline here. Let's say that this is our incline, and we do have our angle there, and we have been given that the angle is 19 degrees. Then you are now going up. You can't see that color, right? You are now going up. Okay. Okay, so now the question is saying this distance which is there is 15 meters, but we don't know. You need to be very careful when you are calculating the potential energy. We are saying that mgh, h is the height, this distance is not the height. So the h on an incline, we are getting this h when you are calculating the potential energy. Is it okay? We talked about that last time. Then the velocity, now that velocity, is it initial or final? That velocity which we have is initial. Yes, so that is initial. So we have got initial velocity as what? 11 0.0 meters per second. The final velocity when it goes up there is going to be 0. Okay, now when there is friction, guys, the formula doesn't change. What are we saying? If maybe you have managed to get the point which we have just said, when there is, we are saying that the formula is always the initial has to be equal to the final. But if there is friction, what do we do to this equation? If there is work done by the friction, what do we do to that guy?
We can either subtract the initial
Okay.
mechanical energy
Or
add.
exactly. So if you want, this is the, okay, in short, this is the original one, the original formula. Get it from here to say it is the mechanical energy initial has to be equal to mechanical energy final. This formula works when there is no friction. When there is friction, it's either you say mechanical energy initial minus the work done by the friction has to be equal to this guy, or you say mechanical energy initial has to be equal to the mechanical final plus the work done by the friction. So you get these, just get one. So here we are going to use this one. Okay, so that is what we are supposed to do there. So the question there is not even difficult. The question, so we are going to say that we are going to write there the mechanical initial has to be equal to the mechanical what final plus the work done by the friction. The mechanical there, it is always half, or sorry, it is always the potential initial plus the kinetic initial has to be equal to, here it is the potential energy final plus the kinetic energy final plus the work done by the friction. So this guy, the formula doesn't change, is mgh, but which h? H initial plus half mv, which v? Initial squared has to be equal to mgh final plus half mv final squared plus the work done by the friction is what? Is Fr times d. Simple, right? Then from here, what do we do? Now from here, what we're supposed to do is this. First, we don't have, with this, the final velocity is 0. What are we going to say about the final, this guy? What's going to happen there?
It is 0.
It is 0. Is it okay to everyone?
Yes.
So now what's next now? If we don't have that guy, what are we supposed to do? The initial has to be cancelled, right?
Yes.
Yes. So we are going to cancel this. Where is it? Yeah, we are going to cancel this. We don't have the final velocity. Okay. What else are we supposed to do?
Even at the initial point, you didn't have the potential energy because the ions were received at the right.
We didn't have
The zero potential energy, initial potential energy was zero.
the initial potential energy will be 0, right?
Yes.
Okay, so let's put there. What are we going to get if we put the initial energy which is going to be 0? So we didn't have what? Initial energy. So this one is going to be 0. So what are we going to have? We are going to have half mv initial squared. Then if I can shift that one, I'm going to have minus mg h final. Then I have this one. Are you able to see that side? For the sake of recording, let's do this. We are saying that if we have cancelled those guys, then we are going to have half mv initial squared has to be equal to mg h. Then what else do we have? Not this one, guys. We are shifting that guy to the other side, right? I want us to do direct. We are shifting this guy to the other side, and it's going to be minus mg h final. Then this one has to be equal to the frd. Okay, before we continue, any problem there? Do you have questions?
Sir, do we have mass in our statement? We're not supposed to equalize.
It's okay. Yes, we are going to do that. Don't worry. We are going to do that when it comes now, because we are now going to friction force. So what is friction force? According to the incline, is mu m normal force, which is mg cos theta, right? So we are going to replace this one where there is friction. Then I'm going to have half mv initial squared minus mg h final has to be equal to, that one is mu times mg cos what? Theta times the displacement. We don't have mass, so therefore the mass is going to go. And then
This equation just the same as when you just put us in the what? The what? The mechanical advantage is equal to from the what? The non-conservation force.
what are you saying?
When you just put on the left side, you put the non-conservation force, and then on your right, then you put the conservation force, which is the mechanical, the potential, the kinetic energy plus mechanical plus potential energy.
I can't still get your point. You can come again. What are you saying? Come again, sir.
When you put frictional force is equal to potential energy plus mechanical advantage, it's the same.
When you put friction force,
Yes, it's equal to change in potential energy plus change in kinetic energy.
when you say the work done or just friction force, the work done by the friction force,
The frictional force
then the work done by the friction force is equal to what?
is equal to change in kinetic energy plus change in potential energy.
Exactly, it's the same. And that's where it's coming from. It's the same because this change, the change in potential energy, is just basically the potential energy final minus the initial. So this initial is going to go in that direction, to the other side. Then we said that since this one is going to be negative, when it goes to the other side, it's going to be positive. That's where now we are now there.
It confuses me. When it comes to here, I usually get it from there.
Or usually get it from there. It's the same. It's the same. You can say it's the same thing. If you want, okay, it's the same thing, sir. Even if you get it from here, you say the work done by the friction force is going to be given by change in PE plus change in kinetic energy. Then now, since change in potential energy is the potential energy final minus C, so you are going to have the potential energy final minus the potential energy initial. So this one, you are going to shift it to the other side. We know that the work done by the friction force is negative, so this one is negative already. So when it goes to the other side, it's going to be positive. Now, meaning it's going to fall now there. These two guys, that's why here is now positive, and we have shifted this negative, which was the initial here, to the other side. Then we have got these guys. Have you seen?
I've understood now.
You have gotten the point, right? Yes, it's the same.
Sir, yeah, when cancelling M, according to Matt's point of view, when you cancel one M, Leaving the other side.
Okay, okay. So what it means there, sir, is this. We have this. You are confused how we have cancelled the m, right? Isn't here is the same as if I can factor out m, then I'm going to have m open brackets. I'm going to have half v initial squared minus gh final. Oh, sorry, final. Then has to be equal to mu mg.
Now I'm going.
Oh, you're convinced now, right? Anyway, so that's where now those guys will cancel out. It's the same. Okay, so let's continue with our problem. Now we are saying that there we are going to have have even cancelled. We have, if we are following, we are supposed to have half v initial squared minus gh final. Then this one has to be equal to mu times g cos theta d. We are together up to this point, right? We want to calculate the mu. Let's divide both sides by g cos theta d, both sides by g cos theta d. So, genuinely speaking, I said that this h which we have here is not 15. It is which one? This h. So how can I find this h? How can I find this one? I do have that one. I do have the angle. 15 sin. Yes. So it's going to be 15 sin what? Sin 19, right? Yes. So it's going to be 15 sin 19. So what is 15 sin 19? .80. 4.88. So that is the height which we are supposed to use there. So it's going to be, let's now plug in the values. We are going to have mu as this one is going to give us half. The velocity is 11. We square it minus 9.8. If you want, you can just put it there direct to say times 15 sin 19 degrees. Then divide 9.8 times cos of 19 times the displacement is 15. What's the answer? Tell me the answer you're getting. Mm. 9.8 times 15. Let me write it. It's 9.8 times 15 sin 90. Oh, final answer is what? Yes, it's 4.8. For you to get this h, we have said that it's going to be 15 sin 19. So isn't it 4.88? Yes, I've just replaced this one where there is h with 15 sin. It's the same thing. Sure. Tell me the answer you're getting, guys. Tell me the answer. Mu 0.0909. It's okay, just like that. And we can say that mu mu k is going to be 0.091. Is it okay to everyone? Ask. This is the only time to ask, guys. Ask. Are you still confused? Are you still confused? We go to the next question. Yes. Work energy theorem, you can use it, but in most cases, me personally, I don't like using that one. Work energy theorem, you know that? Okay. Work energy theorem is going to be equal to change in kinetic energy. So you're going to use this one. So it's going to be the work net. Now you are going to find, okay, let's do this. I'm going to solve using, sorry? Yeah, even here it can work, but it's just a long process. But the best thing which you can do, sorry? Yes, it's okay. It's okay. Okay. So can we solve using work energy theorem as well? Okay. Since you know what, yes, since you know what to do, tell us what we're supposed to do. We follow your method. Go ahead, sir. Boss. The guy has gone again. Okay. Are we supposed to solve this question? Because this question, I remember, I gave you in the group. You managed to solve it. Are we supposed to solve this question? Okay. What of this one? We do this one. Okay. So let's solve this one. So are you able to see the question clear there? Okay. What over here? You can see now, right? Okay, so the question is saying a steel broke. What do you mean? You can't see clearly. What over here? You are just sick. Okay, so the question is saying a steel block weighing 12 newtons is pulled up an inclined plane of 20 degrees above the horizontal by a constant force of 7.35 newtons, which makes an angle of 10 degrees above the inclined plane. The block starts from rest and is pulled 2 meters along the what? The inclined plane. The coefficient of friction between the block and the inclined plane is 0.20. Determine A, the work done by the block by the force. Determine the work done on the block by the force. B, an increase in potential energy of the block. C, increase in kinetic energy of the block. D, the amount of work required to overcome the friction force. So before you solve this question, the diagram has been, the free body diagram is already there for you, or let me say the diagram is already there for you. Now just draw the forces acting on this object, then you are home and dry. So let's draw this guy somewhere here. Let me put this guy here. Okay, I want to put I want to get white. I want to put that incline there, and you should tell me if you are able to see. So we have got an angle there which is 20, and we have got an object which is somewhere there, the block, and they are saying that this block, the force has been applied at an angle. So basically the angle between there, it is what? It is 10 degrees. Then we do know that we are going to have the normal force in that direction, which we are going to call Fn. At the same time, we are going to have that force which we are going to call the weight force, so it's going to be mg. Then the normal force is supposed to be with that guy again, then again it has to have that guy. So this line, we always know from forces to say it's going to be mg sine theta. Then this guy is always mg cos theta. And we know that the force is going in that direction, but there is also Fg which is going in this direction. And from the rules of inclined plane, we know that Fg is always mg sine theta, because they are moving in the same direction with this guy. At the same time, the Fn is going to be equal to mg cos theta. Then now, after coming up with that information, what else do we need to know? As you can see, this force has been applied at an angle. Okay, now that force we are going to call in this direction is going to be F cos theta, and in that direction is going to be F sine theta. Meaning we have got the Fx as F cos theta, at the same time Fy as F sine theta. What you need to know again there before you go anywhere, the theta for this guy is what? The theta here is what? Is 20. Again, the theta there is 20. But the theta for these guys, it has been given there as 10. The theta there is 10 degrees. The theta there is 10 degrees. Is it okay before we continue? Is it okay to everyone? Okay. Let's now come up with the data before we do anything. Basically, this weight force which have been given, this mg, the one we are calling it as mg, is the weight force. So we have been given the mass times g already, meaning where there is mg here, we are going to be replacing with what? With 12. Meaning this guy is 12, that guy is also 12. Because mg is the weight force. Now, after that, we can now come up with the data upper side up. Let's come up with the data here. So the data which we do know the force, which is 7.35 newtons. We also do know the mg. The mg, which is the weight force, is 12 newtons. Then what else do we know? We also know the distance in this direction. We have been given by this 2 meters. So the d is 2 meters. What else do we know? And that's all. Let's start now solving the question. No, there is also mu, the coefficient, right? We also do have the mu as 0.20. Part A. Part A is saying determine the work done on the block by the force. When they say the force, I even mentioned last time, they're just asking about the work done by the applied force. So in this case, which one is the applied force? The F sine theta. The applied force. You have changed again?
Fx cos theta.
Okay. So the work done by the applied force is going to be equal to m, or is going to be, the force there is Fx, Fx times d. So what is our Fx according to the information which we have here? Is here. The Fx is F cos theta. So it's going to be, the work done by the applied force is going to be equal to F cos theta now times the displacement. Let's plug in the values. The force is 7.35 times cos what? 20 degrees times the displacement 2. Find the answer. What's the answer? Get your calculators. Get your calculators. No. It can't be that one. I thought maybe the guy said 13. I thought maybe he said, yeah, 14 point what? 14 point what?
14.48.
Just like that? Okay. Anyway, let's put. So Jaws.
Yeah, but it is 477 now. I just
You just round it off, or you just saw the answer there?
no, it's 14.47.
Okay, thank you. So now, is it okay to everyone, guys? Let's be honest here. Girls,
Sir. No, sir.
Yes, sir.
is it okay?
Yes, sir.
Guys, is it okay to everyone? I know there's someone here who is behind, but definitely they don't want to come out. We are okay, we can continue. Okay, part B.
He's saying it's not okay. The other guy is saying
Yes, sir. Confess, Papa. It's not okay. Where exactly?
the final answer, sir.
The final answer is 14.48 joules.
When you punch on the calculator, it is giving me 13.8.
No, it can't give you that one. 7.38 or 7.35 times cos 20. Sorry. Oh, it's 10. Sorry.
It's cost 10.
It's cos 10.
Yeah, on the other side.
Is 10 times the displacement 2. So are you still getting 13 when you put 10?
No, sir.
Okay, thank you. Nice observation, actually. Thank you.
So the guy who give. I will give what? You guys. I was punching 10 in a person.
Okay, let's go to let's go to B. B is saying an increase in potential energy of the block. So what we need to understand, guys, is this: kinetic energy. Okay, in short, they are saying change in potential energy, right, or change in kinetic energy. When you see that they're asking about this guy and you don't have the velocity, always the method which works in most cases is this one. The work done is equal to change in kinetic energy. Have you seen? Ella, people.
Yes.
You are just. I'm saying. The question is asking us to calculate what? The work done by the what? The increase in what? Read the question, part B. What is it saying?
Increase in potential energy
So I'm saying that such kind of questions we use work energy theorem, whereby yesterday we said that the work net has to be equal to change in kinetic energy. This is the formula which we can use because we can't use kinetic energy is equal to half mv. You get my point, right? So we can't use this formula because we don't have the velocity. But if we do have the final and initial velocity, we can say that initial change in kinetic energy, that is the increase in kinetic energy, is just basically the change. Oh, the question is asking about the potential, right?
Yes,
I'm on part.
so we can just find
No, I thought maybe it's part C. Okay, part B is saying increase in potential energy. Okay, let's find this H. How can we find that one? So H, without even thinking, is going to be 2 sine 20, isn't it?
yes, it is.
So what are we supposed to do next? So potential energy, yes, to punch. Potential energy is given by mgh. So h, where there is h, we are going to replace with that guy. Then we are going to say pe is going to be, do we know the mass? We can calculate. Weight is given by mg. We do know the weight as 12. We don't know the mass. We know the 9.8. So what would be the mass?
That's the same, like you just replace the weight force there where you can.
Oh yeah, it's the same. It's the same. It's the same. It's the same. Actually, why are we even? Yeah, it's the same thing. It's the same. We can just replace this one with 12, right? Then we say 12 times 2 sine what? Sine 20. Not so? Potential energy is going to be 8 point what? 208 joules. Any question? Okay. We go to part B. Oh, part C, sorry. So part C is asking about an increase in potential, an increase in kinetic energy of the block. That's So why here we have just used the direct potential energy is equal to mass times g times h. Even this one we can use that one, but we don't have the velocity. Have you seen? If we have the velocity, then we can use this formula to say half mv squared. But we don't have the velocity. Therefore, we do know that the work, or the net work, we do know that the work net is equal to change in kinetic energy. Meaning, if we can calculate this one, if we can find the work net, this work net is going to be the answer for increase in potential energy. Oh, sorry, increase in kinetic energy. Does it make sense? So if you yes, if you can remember very well, we said that if I want the second class we had for work energy and power, I said that if I want to get the work net, what should I do? Someone to comment on that. What do we say about that?
Change in kinetic energy.
Sorry? Not that one. We know that change in kinetic energy, we want to find this one is going to help us to calculate this one. But I'm saying, we said that if we want to calculate the work net, the second session we had, we said that we're supposed to do what? If you can remember. You people.
The work for the force applied.
Mm-hmm.
You have to find the work for the force applied
Okay.
and the frictional force, then you add them.
Exactly. So if you have got the force, if you have got the work done, there is a force moving in this direction and the force of friction opposing it. Okay, so if I find the work done by the applied force minus the work done by the friction force, that is the net work. So this net work is the one we are saying it is change in kinetic energy. So if I find the net work, that is going to help me to calculate what? That will be the answer for change in kinetic energy. If you are not there, then you haven't managed to watch the video, because we explained this concept. So on an incline, guys, when you have got the work done, okay, in short, on an incline we have got the friction, the Fg, and the force applied. How many work do we have here on an incline, on this incline? I want a girl to comment on that. How many work do we have? Yeah, which one and which one? Yeah, the work done by the Fg, or also the work done by the friction and what? And the applied force. So if we add these guys, that will be our net work, and that will be the answer for what? For change in kinetic energy. Now let's first come up with what we are going to do is this. It's going to be this. It's going to be the work net is going to be equal to, do you think what will be the sign for work done by the Fg? Is it going to be positive or negative? Negative, because it is opposing, right? So the work done by the Fg, what of the work done by the friction? Is it going to be positive or negative? Negative. Work done by the friction force. What of the work done by the applied force? It's going to be plus the applied force. Now let's come up with the formulas. We know that our work net is going to be equal to, this guy is going to be negative. What is the work done? This guy is just basically Fg times the displacement minus, also this one is going to be the friction force times what? The displacement, plus this one is going to be the applied force, which is Fx times the what? The displacement, d. When I find the answer here, that will be my work net. Then I'm going to say, if you're already confused, please, what is Fg according to the incline? Here we're going to have negative negative mg sine theta, mg sine theta times the displacement minus this friction is mu, okay, mu times the normal force times the displacement. But in this case, the normal force is going to be different. Now it will take us back to, if you manage to watch that video I sent, and there was such questions, I think so. Now what we need to understand here, we're going to say the forces in y direction. What are the forces which we have in y direction? We have got the Fn going on in going up, plus the Fy, which is Fy going up, also minus the Mg, which is the weight force, which is Mg. What is Mg? Cos theta. Now, okay, you are too quiet. Are you confused? I want to find the Fn, the normal force, because this one was applied at an angle, meaning there was three forces in y direction. There was that force, there was also that force, this force, as well as this force. You are not confused? I continue. So now for me to find, yes, they are summing up to 0, so we are going to say 0 is equal to everything. So it's going to be this Fn, I'm going to shift to the other side, so it's going to be Fn is going to be equal to this guy. When I shift to the other side, is going to be positive, so it's going to be my mg cos theta minus this fy is this guy f sine theta. Already confused, or we are still together? So my fn is going to be equal to m is 12, so it's 12 times cos theta is what? This cos theta which we are talking about here now is for fy. Oh, sorry, it's for f, is for this guy, meaning the angle is 20. But when we come for f sine theta, is for this guy, the angle is what? 10. So here the angle is 20 minus 7.35 sine 10 degrees. Find the answer for fn. Yes, 9 point what? Can we say why can't we just say 10 newtons? Let's just say 10 newtons. So that is the fn which I'm going to plug in here. Is it okay now? Okay. So let me get rid of this. Then now I'm going to have there, if we plug in the values, the work net. I'm going to have, now the space is not enough for me. Let me write it from here. Let me write it from there. Then I say the work net is going to be, this one is negative.
So sir, there you can just the normal force is equal to mg cos theta.
Just plug in the mg cos theta, this one. That's your question? Just plugging in mg sine cos theta, this one?
Yes.
No, because the angle here, the issue is here, guys. We have this. This guy was applied at an angle. So the reason why we are saying mg is when this guy is just in a straight line, whereby we don't have the force in y direction, another one. So we only have the fn and the normal force, the weight force. That's why we are saying that mg is equal to mg sine cos theta. But in this case, we do have the normal force. We also have the force there, which is mg cos theta. So the forces in y direction, we have got the f sine theta, this one, as well as that one. So when it is applied at an angle, we don't get this one direct, no. We calculate, we are supposed to get the difference between this mg cos theta minus this one. Then that will be your what now? Your fn. When it is applied at an angle. When that guy, the block, is applied at an angle. For you to get the fn. Have you gotten the point, sir? Okay. So let's continue. So we are saying that our work net is going to be equal to what? What will be our work net? So m, this guy, the whole of this guy, we know it already is what? Is 12. It's going to be 12. Is it 12? Yes. It's 12. It's negative. Let's not forget negative. Okay, so it's negative 12. Sine. What is the angle? The angle.
20.
But why are we struggling with this one? I think we found this one somewhere else. We had the 14 there. The applied, that is applied force. So the applied, the applied force we're not going to calculate because we have it already. I know you're already confused. This formula is like this. We have come up with this now. The work net, after driving the formula, we have said that it's going to be negative mg. Is it cos? We said cos, right? I'm asking you, is sine theta d minus mg minus mu, sorry, we have said that is mu, the normal force, times d, plus the force, the work done by the applied. So the work done by the applied force, we have already calculated there, is 14.48. Then now let's plug in the values. So this one, we know it already is going to be negative 12 sine 20 degrees times the displacement is 2 minus the mu is 0.2 times the normal force is 10 times the displacement 2 plus 14.48. Now you can get your calculator and punch. Give me the answer. Negative 12 sine 20 times 2, then that one minus minus 2, that one you're going to get 2, then that one, what are you getting, guys? What are you getting? Hey, you people.
Sir,
Mm.
me, I've not used the 14.8. I've used the one which is not rounded off. So I'm getting 2.268.
It's okay, it's okay, it's okay. You're getting 2.268.
Yeah, 19.
Okay, it's okay. Let's just leave it there. So we can round it off and say 2.268, just like that. Meaning that is the answer now. That is now the change in kinetic energy is going to be equal to an increase now, 0.268 joules. The last question was simple, was determine, is it okay to everyone before we continue? Seems like people are quite
Sir, can you just repeat
Okay.
that was the normal force? Where we have mu n fn.
okay.
What have you done?
But it's okay with everything, right? But only the normal force, right?
Yes, it is.
Okay. Let me repeat the part of. So I'll just explain about the normal force, and I'll say we are going to consider a situation where we have this. Let's say that we have got an incline, and let's have an object there, and let's say that we apply it at an angle. We apply it at an angle. So there we have got the angle there, right? Theta. So you know the principles of so you know that this force is going to have the fx, at the same time it's going to have the fy. Is it okay there? Is it okay, sir?
Yes, it is.
Then we are going to have the normal force in that direction, which is Fn. At the same time, we are going to have that mg. Again, we are going to have that guy. So in this case, is mg sine theta. This one is mg cos theta. Now, always we are saying that Fn is going to be mg cos theta when this guy is not applied at an angle. Then we are using this one. You get my point, right? But what it means there is when now we have got the angle, we do have another force in y direction. We can't just leave that force alone, no, because it is also in y direction. So okay, in short, before, without an angle, for us to get mg cos theta, what we are doing is this. We are saying what are the forces in y direction, since this guy is not moving in y direction, meaning the forces, the sum of all the forces in y direction, they are supposed to give us 0. So what are the forces acting in y direction? We have got the Fn, we have got the Fn, okay, so we have got the Fn and what? Okay. So we have the forces here. When we add, we have got the Fn. Now Fn is going up. What of mg sine theta? This guy is going down, so it's minus mg cos theta. That is the reason why Fn is equal to mg cos theta when there is only two forces acting in y direction. Now in this case, we have got also another force in y direction, but still we know that this object is not moving in what? In y direction, meaning all the forces in y direction, they are supposed to give us 0. So we're going to say that all the forces in y direction, when we add them, they are supposed to give us 0. So what are the forces in y direction? We have got Fn and Fy, they are going up, so they are going to be plus Fn plus Fy minus mg cos theta. Have you seen? Has to give us 0. So if I want to make Fn a substitute formula, then it's going to be Fn is going to be equal to, I'm going to shift this guy to the other side, it's going to be negative, this one to the other side is going to be positive, then it's going to be mg cos theta minus Fy. So what is our Fy here? So our Fy is f sine theta, so it's going to be Fn is going to be given by mg cos theta minus f sine theta. That is the reason now the formula changes when there is angle. Have you seen?
Yes.
It's making sense now, right? Yes.
Very much.
Yes. Go ahead. Mhm. Yes, ask. Okay, yeah. That's a wonderful question. So you check the arrows, yeah? Very important. Sometimes they're going to give you this situation to say it was applied that, for example, let's say you have this. Then they give you that the angle is in this direction, right? Then we will have this. So here what's going to happen there is this. This is more like the displacement, the resultant. So when you have got the vector which is in this direction, we are supposed to go there. We show the arrow there up to we get there. So even here we're going to show the arrow there. This one is going to go down. Again, this one is going to go in this direction. Meaning when the angle is applied in this, like the arrow, if the arrow is pointing the object, the formula changes. Because now in y direction you are going to have Fy is going to go in this direction, same direction with what? Mg. Now, for you to find the Fn is going to give you this. Because the forces acting there, we are going to have the normal force minus the Fy minus mg cos theta is equal to 0. So your Fn is going to be given by Fy plus mg cos theta. Because these two guys are moving in the same direction. Have you seen? So you check the arrow. If the arrow is moving in that direction, meaning even this one is coming there again until it reaches there. If the question was like this, yeah, but I'm tired, then you apply in this direction, meaning that your y was supposed to point down so that you reach there. Have you seen? Have you seen? Sure. So last part I think you can solve it yourself is saying the amount of work required to overcome the friction. So it's just a matter of calculating the work done by the friction. So what is the work done by the friction in that case? Work done by the friction. We have found the normal force already. What is the normal force? We said is 10. So the work done by the friction is going to be given by mu times the normal force times the displacement. So mu is 0.2 times the normal force is 10 times the displacement is 2. What are you getting? What are you getting? 0.2 times 10 times 2. 4 joules. That is the 4 which you can see there.
Sir, repeat once more.
The question is saying amount of work required to overcome the friction is just the work done by the friction. So the work done by the friction is given by the formula. Is going to be the work done by the friction is going to be the friction force, or the friction force times the displacement. So the friction force is mu times the normal force times d. So the normal force we have already calculated using that Shimarong formula. You remember we said the normal force was equal to mg cos theta minus, yes, so that one gave us 10. So we are going to say the mu is 0.2 times 10 times 2, which is 4 joules.
Alright, yeah, I get, thanks.
Sure. Okay, anything else?